Okay, good day to my examiners, Dr. Dayang and Dr. Shafeza. So today, my name is Narin Poniswaran, matrix number 206766. So currently, I'm doing this, my final year project research on a semi-continuous subcritical water process for recovery of palm oil and valuable material from oil palm empty fruit punch. Okay, so before I go into detail of the exciting part of my research, which is the environmental impact and the process involved, let me go a little bit deeper into the background of the study. So as we know, Malaysian oil palm industry is the second largest global producer of crude palm oil in the world. But the problem we face is that 22.6 million tons of EFB is wasted annually. The problem with EFB waste disposal is the land waste and environmental problems like gas emissions and odors. So in order to solve the problem, effective waste management is required, where biomass recycling and methods to convert palm oil biomass into renewable energy is currently being researched by many scientists. Okay, moving on to the problem statement objectives. As we know, the main problem that we are facing here is the complex sugar extraction. The EFP is made up of complex cellulose, which makes the extracting reducing sugars very difficult. On top of that, many researchers have actually found a proper, efficient way to extract oil from the EFB, which is organic solvent. But the problem with organic solvent that we face is that, as we know, organic solvent is very expensive and it's toxic to the environment. As more than that, an inefficient oil extraction occurs because the current method that we actually use is the mechanical pressing method. But the problem with the mechanical pressing method is an inefficient oil method where only 1.5% of oil is actually extracted because of the fibrous nature of the fiber, which actually absorbs back the oil. Okay. Next is the lack of continuous extraction of research. So the current equipment in the lab is actually unsuitable for handling solids. Therefore, an assembly or a modification is required to allow the solid extraction of EFB, to modify it to the so that solid extraction can be done. So what's the main question is that what's the advantage of this semi-continuous subcritical water treatment compared to the batch subcritical water treatment that was done by Purni in 2016? The advantage is that in batch, as we know, batch we cannot produce, it takes very long time, the reaction time is long, and we cannot control pressure accurately because it follows the vapor pressure of the substance, vapor pressure of water. So in this semi-continuous, you can actually control the pressure accurately, and it's suitable for continuous production of EFB industries. This shows that it's more, this semi-continuous subcritical water treatment is more applicable in industries compared to batch. Okay, moving on to the main objective of this research. The first one is to treat solid at a controlled pressure and flow rate by assembling semi-continuous subcritical water equipment. Second is to investigate semi-continuous subcritical water treatment of EFB for three things: extraction of oil, hydrolysis of sugar, and reduction of solid waste at different temperature and reaction times. The last is to analyze and compare results between batch subcritical water extraction by Purni and semi-continuous subcritical water extraction of EFB for higher oil yield. Moving on to methodology. How did I do this project? Okay, the main experimental procedure for this project started off with experimental setup, as the previous student didn't clean, so cleaning was done to the previous subcritical water equipment, where acetone was circulated to absorb all the residue of the pomade used. Next is the assembling of the semi-continuous reactor, where the reactor was integrated into the previous continuous equipment. A reactor was integrated so that solid EFB can be inserted for the extraction process. Next is the raw material preparation, where EFB was collected from Sine W palm oil mill. Okay, and the most important process, which is a subcritical water treatment of EFB, which happened at two different manipulated variable, which was reaction time 5, 10, 15 minutes, and temperatures ranging from 100 degrees to 250 degrees. Next is the analysis of sample, where there was four main analyses done, the oil yield analysis, where the mass of extracted oil per gram of EIP was measured using, total sugar was analyzed using UVB spectrometer using the phenol sulfuric acid method, where the absorbance was recorded. The mass of hydrolyzed sugars was recorded per gram of EIP. Okay, next is the free fatty acids. This was to identify the presence of free fatty acids due to the hydrolysis of the oil during the subcritical water process, which is unwanted. And last is the separation of sample, which is done by the centrifugation method. Okay, next is the results and discussion. Okay, about the results, what is so important about the results? Okay, let's start with the physical appearance. As you can see, the two phase was observed after the centrifugation phase. The first two phase, one is the oil phase, another one is the aqueous phase. So as for the oil phase, as you can see here based on the picture, as the temperature increases, a high intensity of yellow oil layer was observed, and this shows a more efficient oil extraction as the temperature increases. Next is the color. As you can see as well, the color deepens with the rising temperature. This shows that sugar hydrolysis reaction is enhanced at higher temperature. Okay, as you can see on the right hand side, there's an image of the crude palm oil, which indicated by the yellow hue color. Okay, next let's move on to the most important analysis of this research, which is the oil yield, which you're mainly looking at. The main purpose of this research is to extract as much oil as possible. Okay, so as you can see based on this picture, there is at different temperatures 3 reaction times observed, and as you can see, increasing temperature increases the oil yield actually. So this is because at higher temperature, the dielectric constant of water is much lower. It's because that as the dielectric constant of water actually increases, and at a certain point actually decreases, as you can see on the graph on the left hand side. So this shows that the dielectric constant of water is actually the highest at 225 to 250 degrees. So similarly, in this reaction, you can see that the highest, based on the graph, there's about a constant, a slow increase is observed from 100 degrees to 175 degrees. And at 175 degrees, a very steep increase until it peaks at 205 degrees, which records the highest value, and then it degrades. The drop in the oil yield could be because of the degradation of the oil that occurs. Okay, as you can also see, as the reaction time increases, the reaction time increases, the yield is also increased, almost double or triple. This is because in longer reaction time, there's longer interaction or longer time for the water to be in contact with the EFP. So this causes an increased disruption of oil cells within the fiber, which makes oil extraction much easier. Okay, as you can see, the highest yield was observed was actually at 225 degrees in 15 minutes, and the value is 62.4 milligram oil per gram EFP. Okay, next let's look at the chocolate extraction. So as we normally do, as normally used in research, chocolate extraction is usually used as a benchmark to assume, it's actually an assumption used as a benchmark to indicate 100% efficiency of oil extraction. So we did chocolate extraction using 200 ml of hexane for like 3 days, and the value we got 70.2 milligram oil per gram dry EFP. So as you can see here, semi-continuous subcritical water method at 205 degrees at 15 minutes actually 5%. While subcritical water at 220 degrees, we got a value of 84.5%. So this actually shows that semi-continuous subcritical water extraction is actually much more effective than batch. This is because the semi-continuous subcritical water extraction, because of the temperature difference and the precise control in pressure. Okay, so as you can see for the total sugar, so total sugar is also important factor in the sense that the hydrolyzed sugar can actually be useful in the fermentation produced by fuel. Okay, so as you can see here, the increasing temperature of subcritical water actually enhances sugar yield. It increases the ionic product constant, which actually favors hydrolysis. So as you can see here, increasing the temperature, the sugar yield actually increases. It almost double as the time increases. And the highest yield was observed at 250 degrees and 15 minutes, which was a value of 34.2 milligram sugar per gram dry EFB. Okay, so for a comparison, the batch subcritical water extraction was hydrolysis was compared with the continuous, where batch subcritical water extraction, so hydrolysis, we got 200 mg sugar, while semi-continuous we got 24.8 milligram sugar at the same conditions. The difference is due to the minimum volume of distilled water, because when the distilled water is much lesser, it's much more concentrated, makes the extraction process much higher. Hydrolysis process much easier to happen. Okay, next let's look at the solid residue. So as you can see here, that a 77% reduction is actually obtained at the highest temperature and the highest reaction time. So as you can see here, the blue color indicates 5 minutes, red, yellow, and yellow 15 minutes. So as you can see, as the reaction time increases more, because as explained earlier, it's actually related to the hydrolysis of sugar, because as the EFB hydrolyzes into sugar, more and more EFB is being converted into sugar and less EFB remains. So solid residue is lesser. So the longer reaction time has shown that it results in a greater solid reduction as well as temperature, because as I explained earlier. Okay, so as you can see here, the lowest at the highest temperature 250 degrees and the highest time of 15 minutes, 0.23 gram per gram EFB was remained. So which shows this the solid residue of 77% reduction. So as you can see, for the free fatty acid, subcritical water extraction at high temperature can increase free fatty acid levels by hydrolyzing the triglyceride in the crude palm oil. This can actually lead to negative taste and increase refining costs, because we need to meet the 5% free fatty acid limit set by the PORAM, which is the Palm Oil Association of Malaysia. So our main objective here is to minimize the formation of free fatty acid. So based on the analysis done by gas chromatography, the free fatty acid actually detected at 225 degrees and 250 degrees. This could be because at higher temperatures, sufficient energy is required to overcome the triglyceride hydrolysis process, which makes it easier for the triglyceride hydrolysis process to happen. So as for the conclusion, as the temperature increases, oil and sugar yields increase, while the solid residue decreased. So the highest oil yield was obtained at 225 degrees 15 minutes at 62.8 milligram sugar. Higher sugar was 34.2 milligram sugar per gram dry EFB. Lower solid residue was 0.23 gram per gram dry EFB, which actually continuous subcritical water extraction showed 89.5% and higher efficiency than batch. Make the pressure fluctuations regulation better, insulating the reactor, because currently the reactor is outside, so it sets a limit to the temperature. Exploring the continuous treatment by enhancing the semi-continuous equipment design and scaling up the reactor size to handle larger quantities of EFP. Okay, let's move on to the most exciting part of this research. What is the impact of it to the environment? Okay, so as I explained earlier, the palm oil mill actually produces 22.6 million tons EFB annually. And how can this process reduce, or how can this process help the environment how this process can help the environment? So as you can see here, the semi-continuous subcritical water reaction can actually produce, there's actually 3 reactions that takes place, which is the extraction, producing extracted crude palm oil, hydrolysis, where the EFB is hydrolyzed into hydrolyzed sugar sample, and the reduction, where the EFB is reduced into a solid residue. So as you can see on the right-hand side, the extracted crude palm oil, actually based on the results, we got a highest oil yield of 62.8 milligram oil per gram dry EFB. And this extracted crude palm oil can actually be refined to produce a refined palm oil in the refinery. So it's actually considered a product and not a waste. Next is the hydrolyzed sugar sample. So as you can see here, the highest sugar yield was 34.2 milligram sugar per gram dry EFB. And actually this sugar sample can actually be fermented to produce biofuel, which is one of the main attractions of and main attractions of the industry nowadays. Okay, last but not the least, the solid residue. And the solid residue that actually produced it's not only a waste, but can be used as a boiler fuel for steam generation. Okay, what is the effect of this? What's the impact of this to the environment? So as I explained earlier, with the results that we obtained, we can actually reduce 17.42 million tons of EFD waste annually, leaving only achieving up to 77% reduction, leaving only about 7 million leaving only about 7 million of EFP. Next is the production of 1.1 million more tons of palm oil than mechanical method. If you're using mechanical method, if you're using this method, about 1 million more tons of palm oil can be produced. That's a significant impact on the palm oil industry. Last but not the least is the production of 772,000 tons of potential glucose, which can be used to produce biofuel production. So as I hope you can see what is the significant impact of my project, significant impact of my research to the environment, and how we can impact not only the palm oil industry, but the world in reducing waste, as well as the potential of it to produce biofuel, which can indirectly reduce greenhouse gases and climate change. Thank you. Thank you and have a nice day.